All right, in today's stream, we are going to do some stuff involving mesh rendering and making it go faster. So let me, to start, we'll just lay down some context. So this is sort of the thing that I've been showing of this game, and I don't want to show you any more of it. But this is an area called the overworld, and it's a 3D rendering, and you totally can't, it would be easy not to notice that so much because there's so many flat things in this scene. So like all this water and ground, and these doors are still sprites effectively. They're being drawn in 3D space, but they're still sprites. So the only 3D stuff is like these walls are cubes, and then this guy is a 3D mesh. And if you watch the last stream where we made this tweaks file, I rigged up the tweaks file to let us sort of get a more zoomed in view so that we can sort of see the 3D-ness of this. So I can cut down this upscale. Upscale is how high the camera is. So I can cut that down to like 0.5, and that puts us closer. And then the south scale is how far, you know, toward the bottom of the screen the camera is, as opposed to being over the middle of the level looking down. So we could make that go like 3. And so now we've got quite a perspective-y view on the same scene, and you can see more clearly what's going on. And because this is our tweaks file that I'm saving to disk, right, and it's getting hot loaded every time, right, so we can adjust these minutely and stuff. It's not quite as cool as binding this stuff to the keyboard, but you know, these are just global variable tweaks right now. So I can restart the game and that'll stay, right, because it's loading that file every time. So we're going to take this viewpoint for a while. Now, I'm not going to go to any of the bigger levels with more stuff, again, because that'll spoil the game, but suffice to say that the way I'm rendering this little dude here that you see moving around is really slow. It was a get the game engine up and running kind of way of rendering the guy. And what we're going to do today is make that go faster as our main goal. So my main goal is by the time people show up in the office on Monday, the game renders a lot faster because some of the levels really chug at like 10 FPS or something, or maybe even lower. And the second goal, and you'll see why it's so slow when I go show you. Oh, I forgot all the music is always on. I hope the music's not too loud. And then the second thing that we will do is, as a stretch goal, well, let me just say, so the mesh rendering going faster thing is a task that could be simple and be done very quickly, but then again, it's OpenGL that we're dealing with, so if something goes wrong, it could be a giant pain in the butt to debug and take hours and hours. We don't know because OpenGL is crazy like that. So we're going to hope for the best and hope it goes well. But as a stretch goal, if that goes well, then we'll do some like mesh format conversion and fast mesh saving loading kind of stuff like you would do in a production quality game engine. So first is making meshes render faster, and second is like format kind of stuff. How I'm measuring the speed, I'm not measuring the speed right now. But look, sometimes you're just doing things in a way that is bad. So, I mean, if I wanted to spend another hour on the stream or 30 minutes or something, I could put in a frame count. Well, it wouldn't take that long. But it would be artificial. I mean, just take my word for it that it's slow and that this needs to be done. It is true that usually when you optimize, you should make sure you're optimizing the right thing in profile, but I guarantee you that this stuff we're going to do needs to be done. So let's talk about what that is. Let's talk about what that is. So let's go to the mesh stuff. So, oh no, let's go to triangle mesh. So this is data structures, these are the data structures that are being used to render, and some of this came over from the witness. So, you know, we have different flags for materials, most of which we're not using right now because you saw that our rendering was not very sophisticated. We have all these types of materials, again, most of which we're not using. But the reason we have all these is because these correspond to the mesh format that we're loading. So we've got a common mesh format across this engine and the engine for the witness. And so, you know, if somebody exports something with a power cable material, even though we're not rendering that, we at least know what that's supposed to be. So, but the actual part that's important is this guy, the triangle mesh, right? So the dude that you saw walking around on the screen was represented as this data structure. And as you would expect if you've done 3D rendering, there's an array of vertices and UVs and vertex frames and colors and a canonical vertex map and all that stuff. All that stuff. And we don't have light maps, but if we did, you'd have like light map data and stuff. And again, this is exactly the data structure we use in the witness, so that's fine. I'm not going to go into every tiny thing. Oh, but I'll just say these here are, like, this is all the vertices in the whole mesh, right? This is all the UV coordinates in the whole mesh. This is all the vertex frames. But you don't render everything in the whole mesh at once usually, right? Because usually each mesh has multiple materials. Like if you have a little model of a guy, his clothing might be one material, and his skin might be another material, and his eyes might be another material, and his hair might be another, whatever, right? The metal parts on his clothing might be another material, and usually the parameters, well, usually the shader or the parameters or both of how you want to render each of those materials is different enough that you do a separate draw call for that. So what you do is packed into these arrays, you have multiple triangle lists, and then there's this thing called a triangle list info that for each triangle list tells you what to do. So it says, here's the material we're going to use, and here's where this list starts in that array of all the triangles, and here's how many indices, right? So you'll have one triangle list for the metal stuff, and one triangle list for the clothing, and one triangle list for the skin, and whatever. And there's other things that might need you to change triangle lists. For example, if you want to swap textures, even if it's the same material, you probably have to break the triangle list. So that's just how 3D game rendering goes. Everything I said is very common to like most game engines. So is there any questions about that part so far? Why did I use OpenGL and not DirectX for this game? Because I felt like it. But it's probably not going to be OpenGL in the long term. Any questions about mesh stuff? Like on topic, what is a triangle mesh or how it's working? I'm not going to answer general compiler questions right now. On topic, folks. Do I prefer to use an Uber shader or a lot of small ones? Well, if it were up to me, I would use maybe an Uber shader or a couple of shaders maybe, but that's how I had the witness set up when we started, and then the people who did the main rendering stuff, as our renderer got more sophisticated, felt that the right choice was to use a bunch of smaller shaders. And I have not myself done any kind of measurement to know whether that's true or not, so I'll just believe them that that was the right way to do it. I like the idea of Uber shader because you know, an Uber shader is, to explain that concept, it's when maybe you have one shader to do all those materials, like the clothing and the skin and whatever, and you just set different parameters, right? The nice thing about that is you don't have to write as much code, and maybe you don't have to switch shaders as often, which gives you fewer draw calls. But the not so nice thing about that is that maybe that shader is slower than the more particular shaders, and the problem with that is that that shader happens per pixel or per fragment, where there's multiple fragments per pixel. So a little bit of slowness there really adds up to a lot. So it's very easy for shader's slowness to be noticeable. Let's put it that way. Someone's asking, why not multiple geometries with one material? Because you have to do multiple draw calls, and that's not very good. Do I import or generate binormals and tangents? Our mesh format usually would have that in it. Because for high quality lighting, you generally want that. So this vertex frames here is an array of frame 3. And frame 3, let's see if that's here. Yeah, frame 3 is a tangent by tangent and normal, right? Where this is like the x-axis, the y-axis, and the z-axis. So we have all that stuff. And it's not even compressed. It's 3 vector 3s. You could like store a quaternion or something, except you maybe don't want to store a quaternion because you want the ability for these to not be orthogonal sometimes, depending on what you're doing. Okay. I didn't see Abner here, but maybe he's here. Okay, so let's look at what we're doing to render this mesh that is slow. And there are several things. Let's go to the sort of the user level routine, or there's sort of 2 levels of what you do when you draw a mesh. So one is this mesh draw procedure. So for example, I might iterate over all the entities in the world, and for the ones that have meshes and are visible right now, you call mesh draw with the mesh and the position and the orientation and the scale and the color that you want to multiply by, and maybe there's this override color is like if there's materials where you can poke one individual material, like make it glow or something. Anyway, so that's what that is. And you know, we do some stuff like we set up the transform, and this part isn't trying to be particularly fast right now. So we set up our rendering matrices for that mesh, given the parameters, and then I say, okay, so for every one of those triangle lists, we grab the material according to that list, we grab the texture map name, and then we look up the texture map in the catalog, right? And so the reason this is stupid is because, I mean, you know, anytime you're resolving a name like in a hash table to find something else, which is what's happening here, that's slow, and you don't really want to do that every time you draw a thing, because the way the system is designed, so when you get a texture map back by finding it in the texture catalog, the engine is designed so that the pointer you get back stays valid throughout the runtime of the game. So even if we unload the mesh, that'll still be valid, but it'll say, oh, it's unloaded right now, right? Or if you hot load the mesh, it'll swap out the geometry, but your pointer to the mesh struct will still be the same. So this is redundant work, and so the first thing we're going to do is change this and make it happen at mesh load time. But before we do that, let me show you the other thing that's really slow, because I want to go through a full walk of this system. So what we're going to do to optimize this is at the time that we load the mesh, we're just going to grab all the textures for every material and then stash the pointer to the texture map struct on the triangle list or somewhere, right? So that's fine. Then the next thing we do is for every triangle in that particular list, so the first index is like, okay, what's the first triangle in this list? And then how many indices are there in the list? And for every triangle, I manually grab the data out of all these arrays and call this thing immediate vertex, which will look at what that is, but it's basically the user level version of like GL vertex. So you call this 3 times for every triangle in the mesh. So if your mesh has 10,000 triangles, we do this loop 10,000 times, and you can imagine that's not fast, right? What you would like to do is have the geometry all go to the GPU when you load it, and then just say one time, instead of looping here, just say, oh, draw that triangle list. Okay, draw this other triangle list, right? So we're going to do that as well, hopefully. So let's look at what's underneath this, just so that you see. So the reason I did it this way is just because when you're getting an engine up and running, you want to take small enough steps that you can debug them and make sure they're good, right? So getting immediate vertex running is relatively easy, and then once you can load a mesh, you know, emitting the mesh through immediate vertex is relatively easy. Doing VBOs that we're going to do in a bit is one step more abstract. So, you know, you need to do that to have things go fast, but so far we didn't need things to go fast because, you know, if there's just like one guy, he's not noticeably slow, but if there's like 100 things on the screen, it is. So, let's, like I said, go to look at immediate vertex. So what happens is this does like yet some more useless marshalling of data where it gets a pointer to the current next vertex in a vertex buffer that I'll show you in a second. Num immediate vertices is like how many vertices have we outputted, and it just, that's some struct, and it just sets the fields of that struct and increments the number of immediate vertices. And then when it's time to draw, like if we change the shader or if we explicitly flush, we call this routine called immediate flush that does some OpenGL stuff to like bind a vertex buffer object. We'll go more into this in detail when we get to this part of the thing, but there's a vertex buffer object that represents an array of vertices in memory on the GPU, right? And so we're saying, oh, we want to upload some data into that vertex buffer object from the CPU to the GPU. So we say, well, it's this many bytes. It's the number of vertices times the size of the first one. And here's where the data starts. And GL stream draw is like some flag that I forget. It probably means wait until we're done uploading, or don't wait, or I don't know. Whatever. Anyway, you know, then once we've uploaded that, we say, here's the pointer to the positions, here's the pointer to the colors, here's the pointer to the normals, because the GPU doesn't know, because the vertex format could be packed in all kinds of different ways. So we have to tell it, right, here's where the normals are, here's where the UVs are, and then draw the thing, right? So just doing one draw call is in OpenGL not trivial. So anyway, this part is probably still going to, whoops. This part is probably still going to stay mostly what it is, but it's not, we're not going to do piling stuff into this immediate vertex buffer. Instead, we're going to have a separate vertex buffer for every mesh and do the upload from the vertex buffer object at startup time. Okay. Hi, Sean. All right, so let's do the first thing. This is the easy warm-up thing. Let's go back over here and get rid of the stupidity of looking up every texture every time we're going to draw, right? We even do this thing of like eating slashes at the start of the texture map name and stuff. It's ridiculous. It's ridiculous. Oh, this is actually not good code. Not correct code until we have short circuit and, right? Because if this is like an empty string and this isn't short circuit, we're going to dereference the string. But it's not crashing us right now, so whatever. I'll just put that note there and let me put down short circuit as a topic for a new compiler stream sometime. That'll be fun. All right. Those ats are not used. Those are just for me to search through my code. Okay. So this is dumb. This is probably not nearly as slow as the immediate vertex way that we're rendering, but I'm going to do this anyway because it's hopefully easier. So we're going to say, instead of, instead of looking at the render material map name, we're going to say we're going to say map is, let's put the texture map pointer on the triangle list info for now. We could put it in a parallel array or whatever, but yeah, is list dot map if bang map continue. Hopefully we set that map to something besides null. And then we set the texture. Of course, this is stupid because we're looking up the texture name in the shader by this string. That's another thing that we can optimize later, but I don't think I'm going to optimize that because if we switch to Vulkan or something, that'll be different, and who cares, right? Okay, so we're going to take this. Yeah, someone asked that. Am I getting the shader attributes every frame? Well, the texture name I am. Okay, so let's go to mesh catalog, which is where we load meshes. Or no, we don't. We don't load meshes here. We actually load the mesh in another file, but we want to be able to load the mesh sometimes without instantiating all the textures, because we might be doing a mesh processing tool or something, right? So here we're going to say load triangle mesh, and then load textures for mesh, right? And where should we put that? Let's put that in draw. Load textures for mesh using mesh. And let's just paste all that code from before. Let's copy this loop here because we wanted this loop. Now we don't need to say mesh dot because we're using. Actually, you know what? Let's do using list. All right. So now we got to go to the mesh, and we got to say in our triangle list info, we're going to say map texture map initialized in load textures for mesh if you call load textures for mesh. All right, so material index. Right, so we look up the first name. You can have multiple textures for a render material, but we've got a simple renderer right now, so we only care about the first texture, which we know is the diffuse texture, if it exists. We'll just continue if we don't get a map name, so we don't have to indent. So we eat the slashes, we find the texture map, and then if we find the map, then oh, shoot. Let's not using this list because I don't want to have this ambiguity of map versus map. And we're not getting much usage out of that anyway. So if map, list.map equals map. In fact, we can just say that, and if no map, let's go back to the logging printfs that I was doing earlier today. Those were in, what was that file called that I spent 3 hours writing? Oh, vars. Yeah. It took me longer to figure that out than to just type it. Load textures for mesh. Error in mesh. I think we store the mesh name. Unable to find texture. Mesh.name and map name. Okay, so that's pretty reasonable. Let me make sure that that's triangle mesh has a name. Yes, okay. See what happens. Undeclared identifier material info mesh dot. All right. It didn't work, obviously. You know what? I still haven't fixed the LLVM backend from the other day, I don't think. Let me see if Josh stealthily did it. No. Okay. What about, why not a metaprogramming thing that automatically grabs the identifier for the function and stuffs it into log print? That would not be a bad idea. And I was thinking about that. I just don't exactly know. Like, this is an arbitrary identifier, so you might want this to mean a whole system. And maybe this particular system is only one procedure, but another system might be many files full of many procedures. So I'm not really sure. Maybe this name should be stored in the context, and then you would never have to say it. You like set it. I don't know. I don't know, man. Okay. We are stuck with printf debugging, so print. Let me just see if we even get that far. Yeah, map name default, all that good stuff. And we didn't ever complain. So the problem must be in rendering. Because let me just, in case logging's busted, you never know. I'll just print that. And that'll be hard to miss, but I don't think, nope. All right, so we're good. We're finding the textures. So, I wonder if somehow, let's print out the contents of that so we can see if it's valid. These look like valid textures, right? Most of them are 1024 by 1024. They have IDs. They're not frame buffer objects, so they don't have an FBO ID, and they have data and they have names. So these all look good to me. And we're getting, so for default, we're getting the same pointer back, so we're not like creating new textures every time we pass it the same name, which would be bad. So that all looks good to me. So let's go back to, I'm very sad that we're doing printf debugging, but that's just where we're at. So let me print here, exiting load textures for mesh. So if we see that, we know that, okay, so it's probably in draw. And it's probably something stupid. So here we are, setting texture, and then done setting texture, and we'll see what happens there. Hey, look. Why is that so messed up? Whoa, that time. Oh, the name. The name is not set. Do I have to set the name manually or something like that? That would just be, no, that didn't help. And I feel like we're getting an uninitialized pointer. That's what I feel like. so in theory, it should be initialized to null, but I wonder if I'm like skipping the constructor or something. Yeah, so look, that is totally not a valid pointer. And it's the first thing. It's the first thing. So, when I load a mesh, let me look at the list info. See here, I was like, I'm gonna make this be uninitialized because I'm smart and will initialize all my members for performance reasons. And that just bit me because it's uninitialized. So info.map equals null because we uninitialize this with dash dash dash. Yay, okay, well my guy doesn't draw. That sucks, but so what is going on? Dash 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 means something should not be initialized. By default, if you just declare a variable, it'll be initialized to its default value, which will be 0, right? Or if it's a struct member, it'll be whatever you said it should be. Okay, so this is great, except I'm not sure. I'm not sure. Okay, so everybody's map is null now is the problem. So for some reason, I don't understand. Oh God, I'm such a noob. Okay, so one of the language features that I've been considering doing is, you know, some version of like const reference, but that's more simple than what's in C++. So parameters, for example, are sort of consted by default. Like you can't modify a parameter now, which is slightly inconvenient sometimes, but it actually gives you a lot in terms of being able to pass things by value or reference or whatever. I don't have that same thing arbitrarily for random data in the code because we don't have good data flow analysis yet. And so what's happening here is these triangle lists are by value. So this is copying one of those by value, and then I'm setting the map on it, but then it's getting thrown away. What I really want to do is take the pointer to everything in the list. And so what should have happened was, the default for this, if you take things by value, they should be read-only or something, so that you don't make this mistake. Yeah. All right, we got our guy. So that's good. Life is good. So let me get rid of these stupid printfs. Stupid printfs. What are we printing? Setting texture, done setting texture, and then there's all this map loading stuff. Okay, now this is success though, because look, it already feels faster to me. I don't know if that's actually faster, but That's a solid achievement. That's good. Now we're going to try and do the VBO thing, and the gods of OpenGL will determine whether we are successful or not. Yeah, Sean, dude, just being able to do dot versus arrow, or not having to do that, is so good. But this isn't the only language that works that way. Like, I think D does that, and I'm pretty sure Rust even does that. It's like a thing, like everybody is so over dot versus arrow. It's, yeah. All right. Yeah, like almost every new language just doesn't have dot versus arrow. So, all right. Let's face the peril. What I'm going to do, so let's go look again at some of this stuff. So here's the actual buffer of those vertices that we fill up when we're doing immediate rendering, right? They're of this format, and it's the only Vertex format that this engine understands right now. It's called XCNUU, which is just the way that I name Vertex formats is by what are the elements in them in order, right? So X is like the position, right? That's X, as in XYZ. C is color, N is normal, and then U is 2 U coordinates, right? So you see that that's what's here, right? It's position, color, normal, UV0, UV1. I'm throwing away other information. Like I said, we have the whole tangent frame in the mesh. I'm throwing away the tangent and bitangent right now. I'm throwing away, I don't know, whatever other info you might have in a mesh. So right now to do immediate rendering, I have some procedures that fill this up, but they're not totally factored the way that I would like to be reusable, so I'm going to factor them. And then, well, I'm going to at least factor the OpenGL like state setting part that does the binding to the shaders for this Vertex format. And then we'll verify that that works. And then we'll try to reuse that. All right. So, okay, here is, I'm going to make a procedure just called set vertex format to XCNUU, and that is going to have all this. We're going to put that at the bottom of the file. We're going to copy this name. Oh, I need to get the shader probably. Right. Pass shader. Oh, wow, we're using, okay. We're using current shader a little bit, which is no good. Why is that not? All right. Okay, okay. So that's a thing. Do I... Right, this can just be... Since this is hard-coded for a given Vertex format, this can just be that. GL Vertex attrid pointer. Oh, because I was using extensions. So this is in the GL extension struct. Did I ever show you guys in one of the streams how I'm doing the GL extensions now? It's pretty awesome. It's using as a metaprogramming thing. Anyway. Okay. So that still works. Successful factor. That's good. So we're going to make for every mesh an XCNUU vertex buffer, and then we're going to make a VBO for that vertex buffer. But as a middle step, so before we make a separate VBO, well, no, let's not bother. Let's go all the way. I didn't show you guys. Okay, people want to see it. Let's look at it really fast. Basically, where are my extensions? Okay, here they are. So I have this struct called GL extensions. It's a lot of extensions in it. So this is just every extension that I might want to use, and as OpenGL expands, more stuff gets added to here all the time, right? So I have this thing of type GL extension, so this is a struct with a bunch of function pointers. Now what happens is at runtime, when you start up, you have to bind these function pointers. You know, you have to look them up in the DLL, right? I actually don't remember how I do this. It's done by a metadata thing, but I actually don't even remember. Let me look up where it is. Why did I close Ultra Search? Why does it take so long to start up? And we're going to look for init GL extensions. Oh, it's in what? Oh, you know what? That's in, okay. That's in the source mod, right. It's in the library. So here's init GL extensions. And the way you do it, actually you don't even use a compile time metaprogram, right? You say init GL extensions and you pass it a pointer to this struct. And then just like what we did with the variable tweak file today, once it has the pointer to the struct, it can get the type info for that, and then it just goes every member in that type info, and it gets the name of the member, right? And it makes sure that you marked it as foreign because it's a C calling convention. So it checks the calling convention for you, which is good. And then we go get proc address and blah, blah, blah. So this is awesome. Our entire extension lookup is this code, right? Plus, you just declare at user level whatever extensions you want. And so, you know, this isn't macros, this isn't anything. This is just regular code. And you just put a new procedure in here, and that'll get looked up as an extension. So it's about as clean as you could possibly make it, which is great. That is a little bit off topic. So, yeah. So we were going to want to make one of these vertex buffers. Okay. So let's go back to mesh catalog. And after we load the textures, we're going to make vertex buffers for the mesh. Yeah, Sean says, some drivers expose the extension functions to WCL get proc address, but don't actually work right. Have to query extension before using. Yeah, I probably should do that. That would just make that one procedure longer, because you have to look in the extension string to see if it's there or something. And then that's slow, so you probably want to put every extension in the extension string into a hash table, or I don't know. It just, yeah. I'm assuming for now that modern drivers don't have that bug, but in reality, like for this particular game, I don't think it's going to ship a GL version ever. I don't know. I mean, maybe Vulkan won't take off, but you know, we'll definitely do. I don't know. I mean, assuming we ship on PS4, we'll do like a PS4 rendering version, and maybe if Vulkan does take off, Vulkan on the other platforms. I don't know. Just GL is bananas because you can't ever really control performance in GL. It's hard. It would still magically work, right? It's just that that procedure, this procedure in the library would need to, up here, like the way I would do it to make it keep being magic is my user code would just be exactly the same. And then in here, I would get the extension string, right? And then in this loop, you know, before, I would still do all this checking. And then before calling wiggle get proc address, right in here, I would say, is this in the extension string, right? And if it's not, continue or whatever. And so the user would still see the same thing. It's just this would be a little longer. And it would be a lot longer if you wanted to accelerate the search through the extension string, right? Yeah. Maybe not a lot longer. If you had enough like just pre-existing standard library like eat next word in string, put in hash table kind of stuff, it might be short. Oh, I missed your comment that the mapping between extensions and functions isn't one-to-one. What? Well, I would still try to prevent exposing that to the user, but then like you wouldn't ever then be able to query anything that the library, that this library didn't know about, right? Because, yeah, that's annoying. Well, I'm not going to worry about that today. All right. So we're going to make the vertex buffers for this triangle mesh. We're just going to allocate it on the heap and whatever. So let's look at the mesh. Remember, we have all this stuff, and we're going to need to make a vertex buffer and an index buffer, but the index buffer is just going to be the same, so we don't need to duplicate that data. So we're just going to make our XCNUU out of this, and the number of vertices is vertices.items. So I'm going to say count is mesh.vertices.items. Destination is new count vertex XCNUU uninitialized. So really all we're using new for here is to compute the size. I could call alloc or whatever, but oh, and also to cast the pointer to the target type, right? But we're not, this means we're not initializing it to default values. So for 0 count -1, actually let's say dest buffer. Here, let's do it this way. For every dest is a pointer, no, 4 by pointer, every dest in dest buffer. That way we get the index for free, or not for free, but we don't have to say the index, right? Dest.position equals, let's using this. Dest.position equals vertices, index. Let's just call it index. Des.uv equals uv's index. Des.normal equals vertex frames index dot normal des. Oh, right, we also have to do a color conversion. So the colors here are vector 4, and we want integer colors. So des.color equals RGB color. This is a float to int thing, colors index. So we got an X. That's UV0, right? And UV1, we'll just put zeros in. So X, let's put it in order too. So X, C, N, U, U. So that should initialize that buffer. But let's just see if that runs, right? Because we didn't change our rendering method, so this should just run. Oh, it's not .items, it's .count. Sorry, .items is what I use in C++, so it's confusing me. Color is not a member of Vertex, XC, and UU. What's it called? It's called color scale. That's going to break my formatting here. Let's... All right. So, oh, what have we done? What have we done? So, I crashed even on the first. What's going on? Did I? So there always could be a compiler bug, so I kind of have to tread lightly. For all I know, I have a for loop, but that doesn't look like a valid pointer. Yeah, okay, so new of an array is busted. No, iterating over? No, yeah, new of an array is busted. So that's going to go in my compiler bugs. It's fine, we can use alloc, but returns a garbage data pointer. So everyone asking me, why can't I have the compiler today? It's because stuff like this happens. Okay, it's fine. We just say dest buffer is cast pointer to, no, cast, let's do it this way. Let's make it an array. Dest buffer is an array of vertex xenuu. Dest buffer.count equals count. Dest buffer.data equals alloc. Count times size of vertex xenuu. So that's really all that new was supposed to be doing for us and was doing incorrectly. That also looks like a garbage data. Is that a correct pointer? What is going on? Am I crazy? Maybe that's a fine pointer. Maybe it's 64 bits, so maybe these pointers are valid. You know, they are aligned to 16 bytes. So, wow, this is like before we even get to OpenGL. So, well, if alloc is broken, nothing can run. So okay, we're dereferencing that memory. I am so freaked out right now. This could be multiple compiler bugs. Let's see. 4, 0, 2, count -1. Dest. It. Let's see what happens there. Oh. Oh, you know what? Okay. See, this is fine. I've been assuming the crash was on the buffer that we allocated, but it's probably not, right? It's probably one of these arrays on the mesh is not long enough or is null. So I'm just going to do this. B, C. This is totally, if I just had the LLVM output working right now, I would have known this like 10 minutes ago, so I'm sorry you guys have to suffer through printf debugging. Yeah, we would have known the crash was there, like, I wouldn't have done any of this. This was still, no, actually the new is fine as well, right? All this that I've been doing is a total runaround, yeah. So new is fine, it's just the pointer looked funny, it's not busted. The colors on the mesh are not set. Okay. Well, if colors.data, else dest.colors scale equals 0. I should probably check this for everything, but let's just do that for now. Hey, it's printing a lot of stuff. Okay, let's stop all these prints. Yeah, I should have thought that the meshes probably don't all have color data. See, this is just me being tired or dumb or some combination of that. All right, look, we've got a guy still. He's not drawing using this buffer yet. This is just me filling the data. Okay, so if dest.normal.data, no, vertex frames.data, else dest.normal equals make vector 3, we'll give it a z-axis. If uvs.data, dest.uv0, else dest.uv0, vector 2, 0, 0. Okay, sorry you guys had to. And I guess I'll do that for positions. Every mesh probably has positions, but what the hey, consistency. If vertices else dest.positioning vector 3. Okay, so we're not going to send any uninitialized data in here. Couldn't I locally overload print to do nothing instead of deleting them all? Yes, but that's goofy. Why would you do that? I don't want those prints littering the code. I don't want evidence of my stupid printf debugging to exist in the future. Okay, so I've still got a dude, and now I've got ostensibly a buffer. So now I'm going to set a VBO. So let me go and look at how that, because I never do OpenGL, so I don't really remember how this works. So let's look at how immediate VBO, okay, so we say GL gen buffers, and it gives you this, you can gen many buffers at once, but I'm not going to do that for now. That's just for speed purposes, to minimize the number of API calls. Mesh.vertex VBO and mesh.index VBO, right? And then those are going to be blue ints. Okay, so those are just things that OpenGL gives us. Now, to load the data, I'm going to do this. OpenGL is weird. Dest size of type of dest buffer times count dest buffer.data GL stream draw. I guess I don't know. I should look up what that means, but whatever. So we'll dump GL for mesh. So dump GL errors just asks OpenGL if there's an error string it wants to report, and if there is, we print it out, and hopefully there isn't. And actually, dump GL errors, well, it's probably doesn't do anything right now, because for some reason, OpenGL just decides to give us comments about things when there are errors. Set, no, let's not set a vertex format in the shader. How do we, does GL buffer data just upload the data? I guess so. Now, how do we get the indices? Okay, that's, do we not use indices anymore? Oh God, okay, this is going to be sucky. Because hey, I guess you use GL draw elements if you have an index buffer and GL draw array. Hey Sean, can you tell me something if you're still on there? Like, do I use GL draw elements if I want to do a triangle list? Is that the right thing? I mean, it looks like that was what I was doing here in this code that is no longer done, but yeah. GL gen buffers, oh. Okay. So let's set dump GL errors to true so we can see. See, it says this buffer data detailed info. I don't care about buffer data detailed info. I want to know if it worked. Let's go pipe more so we can only see stuff that happens at startup. No, it's just giving us buffer detailed info. I don't care about that. How do I make it not do that also? Yeah, GL draw elements is for index whatevers. Okay, so I need to make, well, I can probably make one vertex buffer for all my indices and then GL draw elements, the individual things. Okay, so let me do this part. Right, so GL bind buffer just says this is the buffer we're going to operate on, and then here's the data for it, right? So we do that once, and then we do that once for the indices. Never mind, why can't I just say GL upload data for this buffer and put them both? It's because OpenGL style is like this. I guess the asdo calls probably let you do it all at once. I don't know. I don't know what those even are these days. We don't want immediate VBO here, though. I almost did the wrong thing. We want mesh.vertex VBO. And let's just print these. Okay, so we print those. And mesh.index VBO and size, what's it called? Is it just called indices? Where are my indices? Where are my indices? There's so many members on this mesh. Index array. Index array sub 0 times count. Indices. Mesh.index array, because I don't think I'm using mesh. Mesh.index array.data GL stream draw. All right. Let me turn off dump GL errors again. That's so useless. I mean, it's fine when you're debugging shaders or something, but I don't care about buffer detailed info. Thank you, NVIDIA. Okay, so we're getting a bunch of sequential numbers for our VBOs, so that's fine. Let's check the return value of GL buffer data. Oh, it doesn't return anything. All right, great. So this is all good. I guess that's it, right? I mean, we ostensibly could just draw this now. Oh, right. You are correct. Thank you in chat. This count is wrong. This count is the number of vertices. The number of indices is different. It is that. There are a different number of indices than vertices. The number of indices is the number of triangles times 3. The number of vertices is possibly more than that, or possibly, I don't know. It depends. It's a different number. Thanks for catching that mistake, because that would be sad. Okay. All right. Let's make sure that still runs. Hey, it still runs. So now is the part where we try to do something and maybe it works, but probably not. Okay, so back in draw, right, we had this mesh draw routine. And we did this whole thing where we, oh boy, we're going to want some of this. Let me just paste this here. This is the GL bind buffer stuff that I just copied out of the other file. It's got the wrong variables and stuff. We want to keep this scale color stuff because we're, oh, this is so painful. Okay, we're gonna, it's painful. Okay, this part is what we're gonna ignore. So the painful thing is, you know, in the mesh I stored well, no, I mean, it's fine. So I'm computing some color that's like the material color, some color parameter on the material, but then, you know, if it's dynamically substituted, then we passed in an override color and we're setting that, right? And if you pass in a scale color, we multiply it. So we do some munging to get this color. And then we used to pass that color per vertex. But that wasn't really maybe the right thing. Like it should be a material parameter. So what we're going to do is use the vertex colors. And then we're going to set this as a parameter on the shader. Well, let's get the mesh drawing first. It'll probably have all its colors screwed up. But we can fix that. Okay, so actually, this part we do before out here, right? So we say mesh.vertex VBO, right? I don't understand. Wait, what? Oh God, no, this is wrong. How does GL draw elements work? GL array buffer and GL element array buffer. So we don't GL buffer data this because we've already got the data in it, right? And we GL bind buffer our array buffer. This is such confusing naming. Mesh.vertex VBO, mesh.index VBO, right? Is that right? So we do that for the whole mesh. And then, once per triangle list, we say we're going to draw some elements. They're triangles. There are list dot, I don't know. Let's look at the triangle list. List.num indices of them. They are GL unsigned short. And how do I say the first? Is that the last parameter there? Do I send it data? What? GL draw elements. Draw elephants. Indices. I passed the indices? Can I give it the index VBO? Does anyone? Do I use GL draw arrays if I have the indices in a VBO? Or do I use GL draw elements? Someone who knows OpenGL can tell me. You're saying, no, you don't pass the indices, it uses the bound VBO, then why is there a pointer to indices? I mean, I guess over here it was null, so it must use the bound VBO if it's null. Where does it say null here? I don't see the word null on this page. Is this like an undocumented? The pointer to the indices is used as the offset in the index VBO? So it's not really a pointer, it's like an integer, number of bytes. Because it's OpenGL, like. Anyway, this is right? So I have bound, I think people are telling me this is right. I've bound an array buffer and an element array buffer, which I guess means index buffer. And then I draw elements here. And the colors are going to be screwed up, right? I can't stand OpenGL. Let's see what happens. Oh, it doesn't compile. Why doesn't it compile? Because I pasted wrong? End of input from within comment. Oh, down. I never closed my comments. Is that right? No. There. And the guy does not show up. Yay. See what happens. See if that gives us any useful information. See, I wouldn't frickin' know because of all this noise. People who make OpenGL drivers are assholes. That is just all I have to say about that. I mean, I guess I can turn off my GL buffer data, dump GL errors. I'm still getting them. I don't care about buffer detailed info. I care about when I make errors. Make sure my element array buffer is bound. It is bound. You know what we can do? We can super bind it. Oh, it might not be bound if I switch shader. Oh, right. If I switch, oh, and then there's this enable client state. Does that have to, I don't know. I don't know. Right, here's the thing. So here's where I think if I set the shader, that might invalidate these things. So let's bind them down here, no matter what. Still doesn't draw. I can filter the dump GL error messages based on severity. How do I do that? GL get type. Oh, there is a severity. What are the severities? Severity. The address of an array of variables to receive the severities of the retrieved messages. How? Okay, there's one message at a time. Oh wait, I am, okay, I'm getting a severity. Let's just make that the correct type so we don't have to cast it. And let's just say if severity greater than 0, I don't know what the severities are. We're just guessing right now. Undeclared identify severity, did I? For some reason it's capitalized. Well, that apparently 0 is not right. Is it greater than 1? I mean, it's an enum, right? So it could, tell me the severities. It's just an enum, so there's not even something I can search. Who made OpenGL and why? Severity. I'm looking at random web pages. Debug severity high arb is one of them. Oh, there's a error type? Oh, there's a type. Okay, so if type is equal to this, and we're not going to know this number, so if type is equal to that, whoops. So we'll put that into our main header later, but we need to know what it is. Okay, we don't have any errors. Great. High, medium, low. Yeah, I mean, I already... Okay, let's go for medium. OX9147. Medium 9147, and we'll say if severity greater than or equal to... is high higher than medium? No. Low is higher than medium? Integer-wise? Oh my god. All right. Or high. So high is 9146. If severity is equal to medium or severity is equal to high. I'm so tired. Well, we got nothing. We got nothing. So let's talk about what could be wrong. The mesh colors. Okay, it could be that the mesh is drawing, but the colors are 0 or something. At this point, let's bust out RenderDoc. Let's see what RenderDoc has to say. So, capture executable, C, sokoban, run, tree, soko, debug.exe. Capture it. Sometimes it crashes, but okay, so I hit print screen to grab a frame. Close it. Let's, why are there not 2 color passes? That's weird. Okay. Oh boy. What? That's pretty big. What the hell is that? I guess that's part of the dude. It's like his arm or something. These are all like temporary meshes that... Why is the mesh view not changing as I click on these? Well, see, when programs like this, when I can't even tell, oh, this is the mesh that's bound. I don't know. Dude, I just don't, this is probably a cube, right? Yeah, these are all individual cubes. I don't know why it's drawing a vertex way off in the middle of nowhere. Maybe we're screwing up our cubes. Or maybe that's just the handle to the origin, I don't know. So where's our dude? What am I looking at? I feel like that's got to be the dude, but the mesh output isn't changing down here. This is a problem with like trying to use a debugger that I'm not used to, and etc. I don't, does anyone know how I tell what the hell is going on here? You have to click the mesh view to see the actual mesh. It says mesh output. Is there a different? This is not a 17,000 triangle mesh. So why? What am I looking at here? Anyone? See, I'm just, now it's not even responding to my clicks. What is wrong with everybody? Well, my machine's hung. Let's just wait and see. Maybe I could have debugged this by now if I wasn't trying to use this debugger. Are the indices bad? I don't remember if you had it working with indices. I never really did it with indices. I guess this is just crashed. I mean, maybe it wasn't working right the whole time. Let's try this one more time, because if we get it working, it'll help. Just software. Gotta get more soft. I gotta type in all this because it doesn't change it. It doesn't save it, I mean. Capture, print screen, let's let it save, close. I don't understand, it used to say 2 color passes, now it only says 1, whatever, okay. Clicking there, mesh output. That's not a 5400 triangle mesh. I don't know what's wrong with this thing. What am I looking at? This looks bad though. So I'm not able to see the mesh, but if you look at these indices, every other index is 0. Oh God, did I tell it 32-bit indices when they're really 16-bit or something? I might have done that. See, so like every other index should not be 0. So, yeah, Sean noticed that before I did. Thanks, Sean. Yeah, so we've got our index size wrong, which should have been, I should have thought of that. Let's go. This, by the way, is how graphics programming goes for anyone who hasn't done this. It's like you get something wrong and then who knows what's wrong. All right. But it is good, as annoyed as I was at this program for not showing me things and for crashing. This is way more information than we used to have in the old days when you just had to guess what you got wrong. So here, well, so these are 32 bits. When I created my VBO, does this happen on creation? How does it know how big the indices are? That's in the Vertex format, isn't it? That's, okay. So now I'm in trouble. I'm going to have to make a separate VBO. Because, here we go. So set vertex format to XENUU. Because we're only using one vertex format in the game, well, this doesn't say the indices, does it? How do we say what size the indices are? At GL draw elements. Okay, so the GL draw elements in that it says GL unsigned short, which is wrong. Wrong for us. You know, I should have just paid attention when I pasted the code, because if I had thought, is it really an unsigned short? I guess unsigned long is 4 bytes. I don't know. I didn't define GL unsigned long. Let's do that. So these header files, oh, unsigned in. I just sort of put things in there as I need them, so I sometimes don't have everything. Still don't see the guy. But let's rerun a capture. Let me for sure make sure I recompiled. No, don't save that log file. Okay, we still don't see the guy. We're print screening. Don't breathe for a second. Close it. All right. So now mesh output. Okay, our indices look sane now. So that's one problem solved. Why are there only, why does the vert position data stop if we supposedly kept going? That seems bad, doesn't it? Did we hit the end of the VBO? Is something else wrong in my GL draw elements? Wait, how do I tell it? Yeah, this is dumb. How do I tell it the start of the triangle list? Like, you know, in reality, you just want like draw, okay, this is the count, specifies the number of elements, type, pointer to location. Okay, how do I, what do I put here to offset us to the correct place in the list, is the question. Hold on, I gotta fix this because this is not starting at the beginning of the list. It's starting at the beginning of the index array or something. So I say offset is some integer that is, what's it called? First index, list.first index times index size. Index size is size of type of mesh.index array 0. I probably already have that expression upward, but that's fine. So it's the first index times the index size. That's the offset, and then I'm going to cast to a pointer to void offset, right? OpenGL, you're so great. Okay, we still don't see him. What does the array buffer? We'll look at that in a second. So we're going to run again. Oh, it crashed. Sometimes when the hooks go in, it crashes the game. That's another thing. Sometimes it works. All right. So I guess this is our current one. Yeah, so this is still drawing all that stuff. I don't know what these are. I'm assuming these 252s are kind of part of the guy. No, those are all, I don't know, man. All right. Now I feel like we're giving it indices beyond the edge of the array, which is why it's saying no positions. Well, except why is it running out after 35? I don't understand that. Check Sean's last 3 comments because he's not sure what I'm doing exactly. If you store vertex data, then index data, it's easier. If you store index data, then vertex data, you need to offset all the VPO pointers to vertex data. Or you can store index and vertex data in separate buffers. That's how most people do it. Apparently, that is what I did. So let's look at what I did, because people are asking about that. Recall. See, this is bananas, because it should be relatively easy, and just like the API is confusing. Just trying to do something simple. Okay. Recall that I made a vertex buffer VBO for just the vertex data and an index VBO for the index data. So they're in separate things. You could put them in the same thing, but I got them in separate things. So I bind this to array buffer, IGL buffer data, that to array buffer. So this is agnostic to the element size, I guess. You just tell it how many bytes. I could print this to make sure I don't have a compiler in like the size of or something. And then we do the same for the index array. Right, so that seems correct. So someone's name guy is saying going to 35 makes sense if that's a cube, but I'm clicking on GL draw elements once. Oh, is that that's not the number of elements, or is it? I mean, what are they drawing here? I'm assuming this is the number of indices, right? So this, if it only, I don't know, guys. What would cause it to only have a cube worth of data when we're trying to draw 17,000 things? Like the buffer bind wouldn't have succeeded for this mesh or something, right? Right? Like what? That's sort of what this output seems to be saying, is a very small VBO is attached, or we're somehow starting near the end accidentally. All buffers should be fine with 0 offset, except that then I have to offset the individual triangle list, because that starts in the middle of the index buffer, right? So is this the offset for GL draw elements? Is this the offset into the index buffer, I assume? I assume. I think it is, because the indices come out right. These totally look like these are totally triangle list indices. That's what that looks like. So the GL draw elements, I claim, is correct, because we have good indices all the way to the end. Okay, what's not correct is the vertex data, the GL array buffer. So now the question is, why is that? Is this the wrong thing to bind this buffer to? If I'm using GL draw elements, is that the wrong? I showed how I get the vertex data earlier in the stream. No, it's one mesh per VBO. I don't know what bind points are. If you mean this, okay. Here's I hate OpenGL. Guys, asking me stuff like, are you sure your buffer is correct, is not helpful. I'm not sure that anything is correct, right? Obviously something is wrong, or this would work. Lots of things could be wrong. Let's print out this size for a second. vertex size is this. Vertex buffer size is vertex size times count. Vertex buffer size, and then print VBO here, vertex size here, vertex buffer size here. Mesh vertex VBO, vertex size, vertex buffer size. Am I printing out the wrong thing? Oh no, vertex size is always 44. That's fine. And we've got quite large vertex buffers. You need to reset the calls to GL vertex attrib pointer after the bind because you aren't using VAOs. That sounds logical. It sounds like wait, so these don't look like they have any buffer specific things in them. Oh, but wait. I don't ever call this in draw. Duh. Okay, so I have to bind these things to the shader, these vertex attribs to the shader, or I'm screwed. So we're just going to do this every time. What's it? Is it current shader? What's it called? Let's say current shader. Hey, there's a guy. Graphics APIs. You know, I've done a bunch of streams in the past couple days, and note how I'm just able to crank when I'm in my own area, like just working with regular programming, but something about graphics APIs and all this hidden requirements and state and stuff, it's just easy to get things wrong. I mean, we had multiple things wrong, but, well. Anyway, so this is success though, because this is tremendously faster than what we had. So now I have to modify the shader. That's going to be fun. I'm going to modify the shader to have a per material color parameter. Vertex attrib pointers automatically bind to the currently set vertex buffer object, but not the shader. Okay, so first of all, I am scared to change anything. So that's my reversion point. So now, as we said, we shouldn't have to bind these buffers multiple times, and we shouldn't have to set this vertex format multiple times. So we're going to do all that up here. And this index size even is constant. So we're going to do that. Hey, we still got a guy. Oh, that's so good. Okay, let's get rid of our print. Let's get rid of this dump GL errors because it's just going to slow us down and it's never going to give us any useful information, probably. All right. Things are looking up. Things are looking up. So now, the shader, I forget what shader, is it called Basic 3D? Yeah, it's called Basic 3D. So let's go look at that shader for a second. We have a so in the witness, and these meshes are using the witness exporter. I don't think we really use vertex color except for special cases. For like LODs and stuff, we use it. But for regular meshes, I think we maybe use vertex alpha sometimes for blends. Or no, we use vertex color for blended materials. For multiple materials, we have blend factors between the textures. But for this, we will not. So here's what I'm going to do. For the basic 3D shader, we've got this scale color parameter that's coming out. I should maybe rename that to something, but so we've got that. I don't get syntax highlighting for .gl files. That's a bummer. Okay. So we've got some hard-coded lights, and we're doing dot products and whatever. And here, we're going to ignore this. We're just going to say the diffuse color on this material is just whatever is set to scale color. And why am I using a global uniform variable? This is a disaster. Okay, let me change this. Let's run the game. Let me change this to just like color. Whoops. Oh dear, I messed something up. GL invalid value generated, so we didn't. I can't see the error message in the shader because of all the spamming. Well, I need to do something about displaying shader errors better. Oh, I didn't declare color. Vec4 color. Oh, so nice. Okay, that didn't work. Okay, I don't remember even how GL shaders work. I guess we have to say scale color equal color, right? Okay. So this is not, right, okay, so this com just means this is output for the vertex shader and input for the pixel shader, the fragment shader. So I need to say uniform vec4 material color. Actually, I'll do that here, right, and I want to say this, and actually as a test, I'm just going to say vec3110, right? So he's yellow. Okay, so that's working. So now material color is not set. So what I have to do now is set material color in the code. All right, I should stop going indoors. So I don't remember how to do any of this stuff in OpenGL. Let's see how we set the texture. I can do the same thing. I have all this hard-coded stuff to accelerate that. Okay, I get the uniform location for the name, which of course is slow, and we can speed that up later. and I call GL uniform, right? So we want to do something that looks like shader, current shader, set material color, color vector for shader and material color, right? And then we're going to assume that succeeds. Well, if loc is greater than or equal to 0, else print error tone loc, right? So then we say GL uniform for F loc with for FV is, and then I can't take a pointer to color right now, I don't think. GL get uniform location using extensions. Oh. This is a C string, so I have to do that. 0 terminated and stuff. Procedure call is missing argument value. GL uniform. GL uniform for FV. I should use 4F. Then I don't have to take the address of anything. Location 0, 1, 2, 3, right? Color dot x, color dot y, color dot z, color dot w, right? That wanted 3. I must have just made a mistake when I made the declaration of this in the extensions, because no, it's 5. Oh, 4FV. I left the V. 4F. Do structs have default and named parameters? Yes. Okay. So let's set the material color in mesh draw. Set material color, make vector 4, 1, 0, 0, 1, which should be a nice red, a solid red. It worked! Which means all I have to do is set material color of F color. Hey, our brick walls are somewhat darker, I think, because, why are we getting tone loc errors? Okay, so this isn't totally working, but it's kind of mostly working. I don't think the camera won't follow me here if I go off. So this is good. We did our main goal. I don't think I'm going to do the stretch goal tonight because I'm going to go to bed, but we'll do the stretch goal next time. Maybe tomorrow. So I have this whole separate thing called box. Is it box? Is it cube? Oh, block. Draw block entity that also can set the basic 3D shader. Okay. Here's why we're getting tone loc errors. So let me go back to set material color. So this is just all this material color stuff is just a temporary hack until we sort of get our real shaders going, right? Because the current shaders are not very sophisticated. So I'm going to just check if current shader is shader basic 3D, which is the only shader that understands material color, then we'll set material color. Okay, so now we've got no tone lokes, and we'll do the same thing here after we have the color, because this is putting this in vertex color, but shader basic 3D is ignoring vertex color. Color equals ARGB, color, F color. Because this wants a floating point, I'm just going to make a float color, make vector for 1, blah, blah, blah. F color equals make vector for KKK1. F color equals make vector for F color equals make vector for F color vector 4 is uninitialized. Oh, and this is colon equals. Okay, so that everything's their rightful color. So that is not including the stretch goal, everything I wanted to do today. So we still succeeded despite me messing up some OpenGL stuff and spending a long time debugging it. We have a much happier guy who renders much faster. So let me commit that. Any questions about what happened here today, besides that Iranians are no longer able to come in the country except that a federal judge suspended that? The perspective tile format, world changing, etc. seems very sausage rolly. Was Student Sausage Roll at all an inspiration for how the game is formatted? Not really. It is a little bit similar in format, that's true, but we had other constraints determining how this stuff works that I won't go into. Am I going to use VAOs? I don't know what a vertex array object is. Probably not, because what I just did is going to be good enough for a while, and then we'll probably switch to a different rendering API, right? Which is why I'm doing all this stuff a little bit slapdashily. I mean, maybe if we decide to do a GL version for real, I'll make all of this more solid, but you know, because you don't want stuff like this in your code. That's just dumb. But you know, it's going to be fine for now. This was just graphic programming. This was not really testing a language feature. The earlier stream today was a sort of a test of the introspection feature to do the variable tweak file loading, and you can find that on YouTube. Am I going to abstract the rendering API? It's as abstracted as it needs to be. I don't see, how would you abstract it more? I mean, forgetting dumb stuff like this, right? What you would really do is you'd query your shader for, like, you know, which strings it wants, and then you'd have some flags on it or something. But that aside, what would you do? If not OpenGL, what would you use on non-Windows platforms? Well, everybody says Vulkan is the future, so maybe that. I just really don't like OpenGL, so I'm willing to try anything at this point. Oh, so you mean OpenGL, DirectX, whatever, Vulkan. You don't need to make this code more abstract than it is to support multiple rendering APIs. All you do is you make a different version of mesh draw per backend, and you if-def them, right? Like mesh draw is at approximately the correct level of abstraction. It's just that you would make one for GL and one for Vulkan and whatever. Similarly for all these things, set texture, set material color, whatever. Those would just have different implementations. You wouldn't change the level of abstraction. Yeah, I hope everybody enjoyed seeing me get really frustrated with GL. I'll tell you, that could have been worse. There have been times in my life when it was worse, when I was trying to do essentially the same thing and it took all day, right? I'm glad I only got stuck for like a half an hour or an hour, or however long it was. Let me take out my tone log. Dump GL errors, set material color. Go GC times are now sub-millisecond. Why do you think that that solves anything? GC pause times are sub-millisecond. That's fine, but how much do those pause times add up to? And you know what? 1 millisecond is a really long time in video games, right? So also, this language does a lot of things in other departments that Go doesn't do. So if you're asking me why I don't use Go, watch some of the other videos, and I'll demo a ton of stuff Go can't do. I mean, this whole thing, Go can't do this whole thing that I did earlier today with the tweak files, right? Like, because this required generics and introspection. And Go, I know, doesn't have generics. I'm not sure about the introspection part, but just don't ask troll questions like that, I guess, or I'll boot you. It's a dumb. Yeah, I mean, I feel like OpenGL, I guess it's like Casey was saying, or someone was saying, if you just took the current, here's how things are supposed to go in GL with all the old deprecated stuff, just forget about that for a while and just make a new API that like is clear. I think that would solve most of the problems, right? And then the rest of the confusion is just, you know, because sometimes it's hard to get information back from the graphics driver about what went wrong when something went wrong, but you know, stuff like RenderDoc will help with that. So I really, like, if Vulkan had just been, this is GL with a totally different API, I wouldn't have minded it. Maybe it's good though, I don't know. Yeah, I might like Vulkan. So I think what I'm going to do is, you know, sometime in the future, I'll do a stream where I just stumble my way through a Vulkan tutorial or something, but do it in this language and like do all the API calls and stuff, which will be extra entertaining because you can make a mistake in those declarations and that's super bad. But that would be educational for me. Oh, you know what? So after I call GL buffer data, whoops, draw dot. So here I allocate this buffer and I never free it. I believe after I upload it to OpenGL, I can free it. So I'm going to defer free desc buffer data. See if that still works. It appears to still work. So Yeah. Everything I did this weekend is already on YouTube. I made a new playlist called Game Engine Programming, and this will go on that playlist and there's 3 other videos there. Someone is saying vulcantutorial.com is pretty good. Let's see. It better not be porn that I'm broadcasting. All right. Drawing a triangle. They start with a class. It's drawing a triangle, and they start with class hello triangle application. Somebody lost points already. That's all I can say there. Will there be more streaming tomorrow? Maybe. It depends on what I'm in the mood for. I might just need a break all day. I am already going to be doing some exercise and stuff tomorrow, and that'll eat part of the day. So the question is just, it would probably be tomorrow evening if I do stream, and we'll see. How worried am I about memory leaks with working on stream? It seems more likely to mess up. I'm not at all worried about memory leaks because I don't usually worry about memory leaks because they're usually not that bad. You know, what I do is once in a while, you sort of look at if your program is taking up more memory. You know, you do this. This is level 1 of finding memory leaks, is you just look at memory use as you run, and you see if it's going up, right? And then you know if you have a problem during development. When you're getting ready to ship the game, then you get very serious about memory leaks, and you like audit your memory use and run memory profilers and all that. But for day-to-day development, a minor leak is not going to kill you. And you might just delete that code and do it a different way before it matters, right? So memory leaks are not generally a bogeyman that you really need to worry about, as long as you have the discipline before you ship to hunt them down. But during development, they're not an issue. Someone is asking, when you add a shader batching to a game, do you generally make all the shaders batchable or only the ones that it's called for? Does a selective approach add much complexity to the main draw code? I'm not sure I know what you mean by shader batching. What I would have guessed that meant is draw a bunch of stuff using the same shader and then switch to the next shader, but that doesn't require any preparation in the actual shader. So I feel like I'm misunderstanding the question. So if you could clarify, that would be good. What do I think is the most important thing that new game developers should know? I don't know. There's a lot of good things to know. Probably you should know that making games is a lot of work. It's more work than you think, and so you have to be really productive and work your butt off in order to get anything shipped at all. That's the most useful thing to know. You know, so when I talk about memory usage and stuff, if you wanted to optimize memory, so first of all, this is kind of dumb right here, because I'm allocating a new buffer and freeing it every time I load a mesh. So I'm not that worried right now because I was really worried about drawing a mesh, which is very performance critical time. Loading a mesh, well, that affects startup time and hot loading and stuff. Oh, I need to do hot loading at some point. I don't want to do that tonight because I want to go to sleep, but I'm going to circle that because it's kind of important for that to work for people, and it's not set up to work right now. Anyway, maybe it's not set up to work. Anyway, so what you could do is just have a buffer that's a global and make sure it's big enough to hold this mesh, and resize it, free it, and reallocate it if it needs to get bigger, but otherwise you're using the same buffer for every mesh, right? That would be a totally sensible thing to do, and I'm not bothering to do that yet. But that would also eliminate the possibility of a memory leak here. I mean, we're not leaking because we free it right here, but that would eliminate the possibility of a memory leak because it's a global thing. I mean, I guess when you're resizing it, you could forget to free it, but you probably wouldn't. Why not develop your own OpenGL abstraction that makes everything easier the way you just described? Because adding another layer on top of something never makes it simpler. It only makes it more complicated and adds more bugs. People don't seem to have learned that, but it's true. Adding layers does not simplify. That is what I've learned in my decades of game programming. Do I plan to release a new language at some point? Yes. Is creating a custom memory manager when making a game a top priority? From what I have read, the less mallocs you make, the fewer operating system calls you make. That is true. I wouldn't call it a top priority because a top priority is to have your game running and working, right? If you don't even have it working with mallocs, then doing careful performance-based memory management is even harder than that. So I encourage, just doing the simplest thing first, which involves allocating memory whenever you want and whenever it's convenient and not worrying about it, right? And then once your game actually runs and is interesting and is something people might want to play, then you can go back and deal with this performance stuff. Now, all that said, there is such a thing as painting yourself into a corner where it's hard to optimize. So at some point you get enough experience to know when that's happening and when it's not. But really, as a beginner, it's very easy for things to be too hard and too much work. So you want to reduce the amount of work you have to do to get results. And for me, part of the way I do that is by being very lackadaisical about performance when it's not in inner loops and stuff. I mean, here I even added a whole inner loop just to get meshes rendering that wasn't necessary, right? I was immediate vertexing all the meshes. Yeah. Let me reset. I just realized I think I checked in all that variables to the team, which is going to screw up the viewpoint. In the witness, we have a thing called local.variables, which I haven't added here yet, but it lets you reset the same variables, but it's not checked into source control. So everybody has their own private Idaho. All right, so we'll put that back at 1 and that back at 1. And now we've got an overhead view, which is the standard. Whoops. Do I usually use a custom model material animation format? Well, the formats that I'm using now are all the stuff that we developed for the witness. So they served our needs for that game, and we have tools like we have a tool that exports from Maya into this format. So the stretch goal, which I'm going to do later, is, and maybe it's not worth doing yet, but so in a real game engine, you would actually have at least 2 mesh formats. You would have the general one, like what I just loaded, and then you would have one that corresponds to this VBO that I just made that only has the things that you need to render on this particular platform. And for different platforms, if it's a lower end platform, you might have fewer vertex attributes. In a higher end platform, you might have more complex shaders that want more vertex attributes, right? And so what you would have is you'd have the mesh file that I already loaded, but then after I process this for this platform, I would save this as a like mesh compiled for GL on Windows in a special folder there, right? And then what I would use in production would have already had this operation performed on it, and I would just like load it straight off disk and it would be very fast, right? That's also why I didn't really, I didn't try to optimize this particularly much. And that is just because, this is not really a performance critical operation. Even though it looks like it happens every time we load a mesh in a final shipping engine, this would only happen, when you wanted to process a mesh into the native format. So yeah, real game engines have at least 2 mesh formats, almost always. You were describing draw call batching earlier. Okay, well, draw call batching, the shader doesn't need to know if you're batching your draw calls or not. It's just a shader, so you don't really have to do anything in the shader that I'm aware of. Maybe there's some advanced rendering technique that I don't know about, but I don't know. Have I ever thought about making an OpenGL-like library using the more fundamental OpenCL? No. I'm not super, like rendering libraries aren't really my thing in the first place. It's not what excites me the most. If I did use OpenCL for rendering, I'd try to do something different, like a voxel renderer or, I don't know, implicit surface renderer or something. A renderer that's all treating things as density fields of participating media, right? I do something that isn't just duplicating the paradigm of I'm rendering a triangle mesh, because the GPUs we have right now are really good at that. And I doubt you would do better trying to write something in OpenCL. In fact, the expected result, it would be a lot slower. So if you were going to do that, you want to be doing something different. And then if you succeed at that something different, then you have something really stylish and neato. But that's, not really my bag right now. I'm much more interested in designing a language and working on this new game. How is it having an art team at the beginning of the project instead of them coming in later? If I remember right, you did a lot of work on Braid and the Witness before bringing other people in. Yeah, it's pretty good. It's more expensive, but it also means that we can do more work early on. So, and our team isn't that big, so it's not too expensive. So I'm okay with where we're at. We did also, we were down an artist for a while, because Luis Antonio, who did, he was on The Witness for a long time. After The Witness shipped, he went off to do his own game. 8 minutes, is that what it's called? I don't want to flake on the title of his game. Not 8 Minute Abs. Why am I flaking on the title of his game? I should remember this. 12 minutes. It's not 8 minutes. It's 12 Minute Abs. So, he went off to do this game. And he's been doing that ever since. So we were down an artist for a while, but we've now hired another environment artist and also an animator. So we have a bigger art team. Well, we have about the same size art team as we had when we had the most people on The Witness. You thought it required that the shader accept texture buffers or instance data for all the different model transfer. Okay, yeah, right. If you want to not context, if you want to not have to upload constants every time you change a transform, so like if you're instancing a bunch of things, then yes, the shader needs to understand that. That's like a different level of seriousness of draw call batching though, right? I mean, regular draw call batching has existed since before you could upload constants to shaders, right? And it was just like do everything that uses the same shader or the same texture at once before you switch to the shader. That idea makes sense no matter what level of communication you have with the shader, right? But yeah, because shaders are more sophisticated now, you can get increasingly more serious about what you try to do there. But then you're in territory that actually can change a lot from game engine to game engine, depending on what people thought was a good idea. Are we hiring? Not really. I mean, unless someone was an astoundingly impressive programmer or artist, then we would always consider it. But right now, otherwise, we've got a full house for what we're doing. But if you're like one of the top people, give me a call. Yeah, we get a why does everyone ask me about my .emacs? It's not, let's go look at my .emacs. It's not that interesting. And in fact, it's mostly junk that I don't even use. Look, here's some key bindings. I don't use most of these. I use the split window ones and go to line. I don't use the compiler stuff even right now. Look, a lot of stuff commented out. Look, a lot of Perl stuff that I don't use. I don't even know what all this garbage is. What the hell is that? I must have pasted that from someone's website. I don't use any of these. Okay, I'm setting fonts. Here's a bunch of compile stuff I don't use. You've never seen me use that because I don't use it unless I hit it by accident. This I use all the time. I hit Control T to put a CPP and an H side by side. This is like the one thing that's actually good about my .emacs. And it's not even that good because it won't find them if they're in separate folders or whatever. This is all pasted from somewhere. Oh, and then this is a syntax formatter for the new language that someone gave me. And that's really it. That's all that's in my Emacs. It's mostly stuff I don't use, so I don't know why anyone's that interested in it. Why does everybody ask about this? What good book references would I recommend for game development? Unfortunately, I don't really know of any good game development books, especially if you mean programming. But that doesn't mean there aren't any. It just means that I don't know because, you know, I kind of know what I'm doing right now, so I'm not actively out looking around for game development books to read them. So if there is one that's good, I just wouldn't have been looking for it. If you have very little time for game making hobby, does it make sense not to use something like Unity? I just don't have time to go through small little things, want to iterate fast on game design. Yeah, I mean, you could use something like Unity in that case. If you really don't have that much time and you want to experiment with game design, I would advise to go even simpler than Unity and go with like Game Maker or some other 2D, relatively straightforward game kit. Because Unity is actually pretty complicated and you can very quickly rat hole on like trying to get things to work. But yeah, I mean, if you don't have that much time, do what makes sense for your situation. I'm totally in support of that. Okay. 2.5 hours. That's about how long it always is when I feel like quitting the stream. So we didn't get to the stretch goal today. We did some good Q&A. And I've got a bunch of little scrawls on this piece of paper of stuff to do in future streams, so that'll be fun. I could also take suggestions. I don't know. The stretch goal was just doing the platform-specific mesh saving and loading, which it's not that interesting. Of course, fighting with OpenGL is not that interesting either, so who knows? Who knows? All right, thanks for coming by, everybody. We'll see you later. Thanks for the help, Sean. That was good. I probably would have gotten stuck for longer and gotten more frustrated if you weren't there. So thank you, and good night, everybody. Where's my OBS? I gotta shut it off. There we go. Stop.